Hey guys, welcome to the Cynohub. Today we will discuss one of the most important topic which is Bayes theorem, which is part of the third unit of machine learning subject. Now coming to the Bayes theorem, see here. Bayes theorem is given by an English statistician and philosopher and Presbyterian minister who's named as Mr. Thomas Bayes. Okay, and in 17th century this base provides their thoughts in decision theory, which is extensively used in important mathematical concept as probability. Okay, so we know that one of the important topic which is part of mathematics point of view like probability and statistics. So based on that, he has proposed one new method. He has proposed one theorem. That theorem he is named as a Bayes theorem, and which is proposed by the Mr. Thomas Bayes in 17th century. Okay. Now come to that. Bayes theorem is also widely used in machine learning, where we need to predict the classes precisely and accurately. An important concept of Bayes theorem named as a Bayesian method, which is used to calculate conditional probability in machine learning application that includes classification tasks. Further, a simplified version of Bayes theorem is also used to reduce the computation time and average the cost of the project. Okay. So here anyhow in probability and statistics, majorly we will use that Bayes theorem. And the same thing while we are going to doing any one of the project which is based on the machine learning point of view. So in that specifically coming to that conditional probability situation, when we are going to getting that conditional probability situation, like see that conditional probability in machine learning, at that particular moment we are going to take in the help of this Bayes theorem. Okay, and this one we can also call it as a Navi-Bayes classification, which is part of supervised machine learning. That is one of the important point. Now come to that. Bayes theorem is also known as some other name. Okay, what is that name? Bayes rule or Bayes law. Okay, so this Bayes theorem we can also call it as a Bayes rule or maybe a Bayes law. Bayes theorem helps to determine the probability of an event with random knowledge. Okay, this is the standard definition for Bayes theorem. What is that? Bayes theorem helps to determine the probability of an event with random knowledge. Okay, it is used to calculate the probability of occurring one event while other one already occurred. It is a best method to relate the condition probability and marginal probability. Okay, for specifically for the situation of the conditional probability and marginal probability, this algorithm going to works. This algorithm is to be the best fit at that type of conditions. Okay. Next, Bayes theorem is used to estimate the precision of values and provides a method for calculating the conditional probability. However, it is hypothetically a simple calculation, but it is used to easily calculate the conditional probability of events where initiation often fails. Okay, some of the data scientists assume the Bayes theorem is most widely used in financial industries, but it is not like that. Other than financial, Bayes theorem is also extensively applied in health and medical research, survey industry, aeronautical sector, etc. That means not only in that specific area, in all aspects, in all research areas, it is going to playing very much important. Okay, so now we will see exactly what is the Bayes theorem. Okay, now up to now discussed about the background of that one, who is that inventor, and where we are going to using that one, how it is going to working. Okay, now we will take that exact what it mean by Bayes theorem. See here, Bayes theorem is one of the most popular machine learning concept that helps to calculate the probability occurrence one event with uncertain knowledge while other one has already occurred. See, Bayes theorem can be derived using the product rule and the conditional probability of event x with known event y. That means here we are going to take in two events. One is the x, one is the y. Here the x is nothing but conditional probability of the event and y is nothing but known event. See, according to the product rule, we can express the probability of event x with known event y as follows. here we can write it as probability of x question mark to the y is equal to p of x by y by p of y. That is the equation 1. Second one, p of x question mark to the y, that is p of y by x by p of y by x into p of x. This is the equation 2. Okay. So now the above equation is called the base rule or base theorem. We are already discussed. Okay. So in this, p of x by y is called as a posterior. Okay. This is one of the specific one, that is the posterior, which we need to calculate. It is defined as updated probability of after considering the evidence. Okay. And here, and within that one more term, which is p of capital Y by capital X, is called the likelihood. Okay, it is the probability of evidence when hypothesis is true. Next, p of x is called the prior probability, probability of hypothesis before considering the evidence, and p of y is called it as marginal probability, which is it is defined as the probability of evidence under any circumstance. So here totally three elements we need to consider here. One is p of x, one is p of y, one is p of capital Y by capital X, and p of capital X by capital Y. Okay. So here, now coming to this by taking one example, see. Hence, finally, the base theorem we can be written as posterior equal to likelihood into prior by evidence. So this is the description of those four elements. See, three boxes labeled as A, B, C are the present. Details of the boxes are: box A contains 2 red and 3 black balls. Box B contains 3 red and 1 black ball. And box C contains 1 red ball and 4 black balls. All the three boxes are identical, having an equal probability to be picked up. Therefore, what is the probability that the red ball was picked up from the box A? Now coming to the solution. See here, let capital E denote the event that a red ball is picked up, and ABC denote that the ball is picked up from their respective boxes. Okay. Therefore, the conditional probability would be P of A by E, which need to be calculated. Now we need to calculate exactly P of A by E. Okay, that is the thing we need to calculate. See that the existing probability P of A is equal to P of B of P of C is equal to 1 by 3, since all the boxes have the equal probability of getting picked. Next, P of A by A is equal to number of red balls in box A by total number of balls in the box A, that is 2 by 5. Similarly, P of A by B equal to 3 by 4, and similarly P of A by C is equal to 1 by 4. Then coming to that evidence point of view. Okay, so coming to that evidence point of view, so P of E equal to P of E by A into P of A plus P of E by B into P of B plus P of E by C into P of C. So by taking all these values and doing that division and multiplication and addition, finally we will get the value of 0.45. So P of A by E equal to P of E by A into P of A by P of E. So here 2 by 5 into 1 by 3 by 0.5. So total finally we will get a value of 0.296. That is the P of A by A. So like this we can explain this base theorem. So here the mainly we need to remember that while we are going to get in that conditional probability, it is going to the best fit method, which is called as base theorem. Okay guys, I hope you understood this video very well. We will meet once again in the next video.